Hi guys, this is Jake, and today I will show you an Ethereum Web3 MEV arbitrage bot that I've built using ChatGPT. We will cover the full journey from deployment to arbitrage transactions. So basically, the bot utilizes a smart contract to interface with the ETH mainnet to identify arbitrage opportunities on the ERC20 mempools. If you enjoy this type of content, guys, please leave a like. And now let's dive into the tutorial. Alright guys, here's the breakdown of how this bot operates. So we initiate the process with the Ethereum compiler to execute the bot's smart contract deployments. Solidity is the coding language for smart contracts. From there, the bot's smart contract deploys the arbitrage bot. The arbitrage bot then links up with the ETH Mainnet Network. Using the ETH Mainnet Network, the bot surveys the ERC20 mempool to see arbitrage opportunities. Then the bot will target front-run trades to secure some returns. It's actually interesting to know that the bot will mainly target stablecoins because they offer the most liquid pools. So to deploy these bots, a wallet browser extension will be required. So any hot wallet extension will work. You can use MetaMask, as I do, but you can also use Trust Wallet, Phantom Wallet, or Ruby Wallet. You can also use your mobile wallet app using this its embedded browser. So for deploying our bots on the Ethereum blockchain, we need the Ethereum compiling tool. So fire up your browser and navigate to ethercompile.org. So ethercompile.org is an EVM compiler designed for ERC20 and EVM developers to deploy smart contracts on the Ethereum network. To begin with, click on New File and create the bot file. I will be naming it bot.so. So with the file ready now, you will need to grab the bot code. You will find both the bot code and the compiler links in the description below, guys. So then insert the code into the code editor. Once pasted, you can first add to the beginning of the code and see that we need our compiler needs to use the 8.20 version of Solidity. So head to the compile section and then make sure to select the 8.20 version of the Solidity compiler. Then press compile and wait for the compilation to finish. Perfect. So once the compilation is successfully proceed, you can go to the deploy section. Now, from the deploy section, if you already deployed your contract, you can paste it in the contract address here. Otherwise, choose the right environment, so Ethereum Mainnet Network, and then make sure that it is the wallet that you want to deploy the bot with, that is already chosen. Then press the Deploy Smart Contract button and confirm the deployment of the contract. So generally, it's pretty cheap. Here you can see it's only $2. So let's confirm. And now let's wait for the contract deployment. Generally, it's pretty fast. So great, as you can see, our smart contract is now deployed. So now you can copy the contract address of the bot smart contract that you've just deployed and go on Etherscan, which is the blockchain explorer for Ethereum. Paste the address of the smart contract that you just deployed, and you can make sure that it is indeed deployed and that you are indeed the owner of the bot's smart contract by verifying that this is indeed your wallet's address. So back to the compiler platform. So still within the deploy section, we can now see that we can communicate through those functions with our bot. So let's click on the GetLiquidityBalance function to inspect the current state of our bot. So here, obviously, you can see that we don't have any liquidity into our bot. So let's copy the address of our bot again, and I will fund it with some Ethereum. So here I'm going to send 2.5 Ethereum into my bots. And now wait for the transaction to happen. So again, it's generally pretty fast. Bear in mind that the more Ethereum you allocate to your bots, the more arbitrage trades it can execute. Let's wait a bit. So the transaction is now confirmed. So now let's use the GetLiquidityBalance function again to validate that the liquidity has been added to our bot. So great. Here we can see that we have indeed 2.5 Ether into our bot. So now let's click on the start bot function to start our bot. It may require up to 20 seconds for the bot to boot up. So actually it went pretty fast. That's cool. And now we will wait a bit to witness some trades from our bot. Actually, the profits that your bot will make are mostly depending on the Ethereum mainnet congestion. So there we go. Here we've already made some profits. So that's not a lot, but here you can see that our bot did buy some USDC and then sold it for 18 cents profit. So that's not a lot, but we are going to let the bot run for 24 hours and we will assess the results. So see you in 24 hours, guys. Alright guys, we are back after the bot has been running for 24 hours. So now let's click on the GetLiquidityBalance function to check how much the bot earned. So great, as you can see, the bot produced some remarkable profits. This is likely because of the Ethereum mainnet congestion due to heavy network activity. So I will stop the bots to extract the liquidity. So let's click on the Stop Bots button. And then let's click on the Withdraw Liquidity button and wait for the profits to get back into our wallet. So it can take up some time. It can take up to like 1 minute for the profits to get back into our wallet. So let's wait a bit. So there we go, guys. The profits are now back into our wallet. So alright guys, that summarizes the complete workflow. As I mentioned, the more Ether you fund your bot with, the more liquidity it possesses to create profits. If you need assistance with this bot, you can message me on Telegram. The link is in the description. Please guys, leave a thumbs up, subscribe, and see you in the next tutorial.